Okay, so working with different scripting environments is going to be something that's really, really beneficial to you, especially if you want to keep your system clean. And the way that I'm going to show you to do that is actually using the Anaconda distribution. So if you've downloaded Anaconda and you've installed it on your system, it already has this built-in way of switching between environments that are installed on your computer. And each environment is really like a fresh install of Python. It's basically if you tell it to install some new environment, it'll install whatever version of Python you want. Potentially could be the one that's the same on your system, and it doesn't have any packages installed. So you'd have to tell it which packages you also want to be included in that environment. Now, you might think that that's a real waste of space because it's installing all of these different packages, but actually it's pretty smart. So it retains links to the master packages that are maybe installed if you've installed Python in your root directory. It'll try to keep all of the links to things that you have in your master packages whenever you tell it to install. So if you were to install something, say like SciPy or NumPy, if you already had those installed in root, it would actually just still be using the environment that's in root when it can. However, you could also tell it to install a different version, perhaps an older version of NumPy, or any of the packages that are there, and then it would download and install and keep that only installed inside of a specific environment. Now, why would you want to do this? Essentially, it's because you don't want to mess up your system architecture. There's lots of different compilers and different system settings that you have. If you're running on a Mac or Linux, they have Python 2 installed, and really sometimes you don't want to mess with the environments and the different packages that are already installed on your system. So having an environment there really keeps things separate from what the operating system uses Python for, and then what we're going to be using Python for. Also, you might want to install older versions so that you can actually check whether some of the code that you wrote might be backwards compatible, or there might be only a Python package that's available for Python 2, in which case you'll want to have a separate Python 2 environment. It's a very, very common reason to have it, right? You're wanting the different versions of Python. So the way that the Conda environment works, it's a multi-step process. All you have to do is name the environment that you want. You have to tell Anaconda what packages that you want to be installed inside that environment. And so this is a way of doing those first two steps. I could say Conda create, and the name of the environment is going to be my first environment, but it can be anything that you want. For example, on my system, I have an MLENV environment that I use for my machine learning environment. Anything that happens after the name right here are additional packages that you might want to install. And NumPy is a very, very common numerical computing package that you might want to install onto your system. You can also give specific versions of things that you want to install. So if I were to create another environment called my Python 2 environment, I could tell it that I want Python equal to Python 2, right? So Python version 2. And because I've told it that I want this new environment to be Python 2, once I tell it to, also install NumPy and SciPy right here, it will install those such that they're compatible with Python 2. Everything batteries included. Now, when you want to switch to an environment that you're using, you'll have to actually say source activate and tell it which Python environment that you actually want to be using, right? If you don't so let's say you open up a terminal and just type Python to open it up, you're actually going to be inside the root directory. So you're not inside any particular environment, you're just where Python was installed, right? So if you don't switch environments, you're logged in as the root. So once you activate that source, you can install additional packages as needed, right? So you don't have to tell every single package that you want installed for Python 2. I could actually switch to this Python 2 environment and say, I also want to install the Jupyter, right? So I could say Conda install Jupyter after I've run source activate my Python 2, and it will only install this Jupyter environment, Jupyter package inside of the Python 2 environment that we have. Now, if we ever wanted to get out of that environment, we could just say source deactivate, and it will immediately take us back to the root directory. Right? So, Conda packages. If you haven't installed Anaconda for your operating system, you really should. So use the sometimes you'll try to install different packages through Conda. You'll say Conda install, and it'll come back and it'll tell you that, oh, this package actually doesn't exist. It's not on the Conda cloud that we actually use, right? So what we can do is we can explicitly look up packages that are on Conda Cloud that maybe aren't officially supported by Conda, but there's someone out there that has compiled these and made them into executables or binaries that we can actually use. And so what you can do is we can search what's called the Conda Cloud to find, if someone has installed the right package for your system. And the way that you would actually do that, let's say if I'm installed on my terminal system, let's say I wanted to look for a package called rpy2, right? And this is a package that allows R and Python to talk to one another. If I wanted to see whether that package existed or had been compiled for my Mac operating system, I would just say Anaconda search, and then I'm going to tell it to use the Conda version of rpy2. And what I would get back is a list of all of the people that have actually gone in here and they have installed the rpy2 system. They're going to tell you what version of rpy2 they actually uploaded into the Conda Cloud, and they're going to tell you which platforms that that person has compiled rpy2 to work for. So which packages does it support, which has it been built for. And if I were to look more extensively at this, I could find, oh, there's actually an rpy2 version up here. And you'll see the actual user that uploaded it was the R user, which is actually R itself, right? And I can see that it's version 2.8.2. It's the latest version of rpy2. So it's like, oh, and it actually works for Linux 64, Win32, Win64, Linux. It's actually all the operating systems they have built this 2.8.2 rpy2 package for, right? So I know that I want to install that package. If after I've looked for this, I can tell, okay, well, I want to install this by saying Conda install -C right here, which basically says go onto the Conda cloud for the user R, right? Grab the rpy2 package that they have installed onto their system, right? And so this is a very expedient way of being able to install packages that have been done by a third party that haven't necessarily gone through the official Conda documentation and gone onto the official Conda cloud, but they're still usable as a third-party system. So let's do a quick example of how we can actually use these systems. So the first thing I'm going to show you is I have a couple of packages that are installed. So if I were to just go in and actually say, okay, source activate, I have an ML environment that I can activate, right? And so it'll go in, activate this environment for me, and now if I were to type Python right here, I can tell that I am in Python version 3.5.2. Okay. Now Control D. Now if I want to get out of this environment, you'll notice there's this mlenv, so it lets me know which environment I'm in always when I open the terminal. I can just say source deactivate. Right here, and now I'm back to the root directory. So if I were to type Python here, it would still take me to 3.5.2, but essentially that's the root Python directory. It's just taking me to whatever I'm used in Python. So I could also do a source activate, but I've also got another environment called gl-env. So if I open this up, essentially, this is where I've installed Python 2. So now if I type Python here, it takes me to the terminal, I can see that, I'm using Python 2.7 in this version. And now, any of the packages that I have installed, I can import and use them in this version of Python. Okay. So let me exit out of that and let me do a source deactivate right here. And now, let me really quickly show you how we can use these. Actually, Jupyter Notebook works with the different Anaconda environments really, really well. So let me show you what I mean by that. So let me run a couple of lines of code right here. So essentially, I've opened up this notebook called 03A environment test. And what I'm going to do here is I'm just going to import sys and import what is the version of the system that I'm using right here. And if I run this block of code, I can see, well, I'm running 3.5.2. I can also, any of the packages that I have installed, let's say I'm using a NumPy package right here. Typically there's an underscore underscore version and then followed by a double underscore, where I can print this out and see, well, what is the version of NumPy that I'm using? Oh, it's 1.1.11. Now, let's say I wanted to do something inside of one of these environments where I wanted to use Python 2.7. Well, if I were to run this code right here, it's going to do the exact same thing. This is Python 3.5.2. And if I were to try to run this line of code right here, it's actually going to throw an error, right? It's saying, hey, you're missing a parentheses call when you tried to call print. And that's because this is Python 2 version of print, not the Python 3 version. So what I really need to do here is switch the environment that I'm working on. And actually, Jupyter has a really, really good method of changing that. If I go to kernel, what I'm going to do is I'm going to change the kernel that I'm running this Jupyter notebook in. And instead of running this ML environment, which is Python 3, I'm going to go down here to my GL environment, which I just showed you was Python 2. So if I click on this, it's going to get rid of all the variables that I had and restart the kernel, right? And so it's like a totally new session of Python. But now let's see what version it's actually using in the notebook. I'm using 2.7. The version of NumPy, if I look at this, it's going to import it for the first time. It's still 1.11.1, and that's just the most up-to-date version of NumPy. That's because the NumPy package works for both Python 3 and 2.7, and they actively develop both. But now if I run this line of code, it'll run just fine because I'm running this from Python 2.7. Okay, so now let's actually try to use this package rpy2 that I told you about. And I'm going to go ahead and switch kernels back. Let's go to Python 3. Let's go to my ML environment kernel. Okay. So let's make sure that I'm in here. Yes, it's 3.5.2. Great. So what I'm going to do here is I'm going to try and use this Jupyter magic right here, which basically says, oh, okay, if you want to be using some type of, anytime you see a % sign, right here, that's basically installing these kind of, they're called Jupyter Magics, but they're essentially submodules that work inside of the Jupyter Notebook. They allow you to use kind of special syntax to call different methods and functions that have been defined explicitly. And so in this example, I would like to load the extension rpy2.ipython. And the reason that I want to do that is because it allows me to use R code explicitly using the %r command. So if I were to load this extension, I would be able to call %r and then actually just call R code right off the bat. So I'll show you how to use this in just a moment. But if I try to actually load this extension right now, I'm going to get an error. And the reason is because I don't have rpy2 installed onto my system. So let's actually go out and Conda install rpy2 in my ML environment, because the kernel that I'm using right here is the ML environment kernel, right? So I'll just copy this. Let's go over here. And now let's source, activate my ML environment, right? So now I know that I'm in this particular environment, and I want to install something new for it. I want to actually go into Conda and install rpy2, which we'll do now. Yes, I want to install all of these sub packages. Great, so it looks like it's completed. Now I sped that up for you. It actually took just a few minutes to install. So let's go back here and let's see if this version of rpy2 actually was able to install on our system. Okay, so let me run this. Oh, no, it's giving us an error. Let's go down here and look. We're going to see set the rhome environment variable to the rhome directory. So essentially what this is telling us is that rpy2 is installed and it was successful, but it doesn't know where to find the language R, right? So let's go back over here to our terminal, and let's see, we're running our Jupyter Notebook here, and we are running our ML environment. So let's see if we can just run R from our ML environment. Oh, and we can. Actually, so it opened up R in terminal. So let's go ahead and quit this here. So Control D. I do not want to save the current environment. So R seems to be working from there. This Jupyter Notebook that we have, though, I launched it not from the ML environment source, but I actually just launched it from root so that it could figure out all the different environments that existed there. So let me open up this terminal here. And so now we're in a root directory. We're not in the ML environment. Let's see if we can call R from here. So right now R, it doesn't know where it is unless we are launched from the ML environment source, right? So it's a different environment. That's where we installed RPy2, and that's also where R is installed. So let's go in here. Let's just shut down this notebook, right? So we're gonna go ahead and leave the page here, and now let's go in here and let's exit out. So I'm just going to Control C out of my Jupyter notebook. So let's now source activate my ML environment that we have right here where RPy2 is installed. And then after this is activated, now let's actually do a Jupyter notebook. Let's open up Jupyter notebook while we're in this source, and we'll open it up, and it opens up a new localhost and home. And so now let's see if we can open up this environment test right here, right? And you know, the kernel that we have right here, because we're launched in ML environment, we really only have access to these two kernels, right? So it's got R and Python 3, and that's all it really knows, right? So because I didn't launch this from the root, there's no other environments that are installed, right? So we're only inside of one environment right here. So let's see, let's go down here and we'll do a import sys. We're still in 3.5.2, but now let's see, now that we're inside of this ML environment where R does know where it's installed, let's see if we can run this extension rpy2.ipython. And what we can see is, yes, it was able to load this magic, right? And so working with environments, you have to be kind of conscious of where you've installed things and where things are. I installed R only inside of the ML environment, and so that's the only place that Jupyter Notebook knew where to go for. So even though I was using these kernels that were installed in it, I had to explicitly open up a ML environment kernel or in the terminal and then run Jupyter Notebooks. Otherwise, Jupyter Notebooks, it's running in root, but it'll use different kernels, but that doesn't mean that the Jupyter Notebook itself is running from the different environments that I have. Once I launch it inside of a specific source, that's all that it knows inside of that environment. And that's what I needed to do here. So we're going to go over some basic R syntax, but let's just see how this RPy2 system actually works. And we'll just do a couple of things here. So when I want to use the RPy2, so now that I've done this load extension, I can actually say %R, and whatever follows after that, it expects to be either some configuration for how Python and R should interact with one another, or it should be R code. So what I'm going to do right here is I'm going to say, hey, I want an output called variable right here. And actually, we could have called this something more explicit. Let's call this pi variable right here. No, we won't. Actually, so basically what this says is that I can run R code after this. And so I can just say, hey, this is actually R code that I have right here, variable equal to 5. It actually goes into R, and it uses the R programming language to initialize this variable. And then it says, as output, back into the Python environment, I also want you to save the value of var, whatever it was in R, also save the value in Python. So if I run this line of code, I can see is var right here is a Python variable. There's also an R variable called var. So if I print var right here, I'm actually in the Python environment, right? So it has a value of 5, and it seems to be an array that I have right here, right? So it's like a list. Okay, great. So %R meant that I'm going to do some configuration such that anything I do in the R environment, put it as an output and save it into this Python variable, and then perform this line of code. But I usually want to do more than one line of code in R. So one of the things I can do with this extension is I can say %R, and that means everything inside this block of code is going to be R code, right? And that says, okay, well, variable, I want to set that equal to 5 times itself, right? So 5 times time, it should be set to 25, right? Great. So now if I were to print var right here in Python, it's still 5. It was not updated. So I updated the variable in R, but I did not update the variable in Python, right? And so what I want to do here, if I actually want to synchronize these two things with one another, what I actually need to do is give this %R magics and some more configuration. I need to tell it how to use input and output into the R environment. And so what I'm going to say is use as input the Python variable var. And whenever you're done executing all the code inside of this cell, update the output with whatever var is. So go find the var variable and also save the output in Python. So if I were to say var equals var times 5 and then have print, it's right here, I can see the value is 25. If I run this again, it'll be 25 times 5, so 125 right here. And now it should also be updating, because it outputs into the Python variable, it should also be updating the variable in Python. So if I print var in the Python environment, so without the %%r, then I'm also going to get it's 125, and it defaulted to a NumPy array, right? So R, the RPy2 environment, it actually, most of the things that it sends back to you are going to be NumPy matrices and NumPy arrays, which we'll talk about later on, right? But essentially, that's what it uses as glue to be able to talk between our Python environment and our R environment, right? Even though they have separate variables in each of them, I can use code like this to just make sure all of my variables in my Python environment and R are synchronized with one another.